Audio Jungle.
For my mini project, I have developed a two-player button game using an Arduino platform that demonstrates key concepts of digital input and output in embedded systems. The game involves two buttons for each player, each controlling a corresponding LED and a third button that serves as a reset function. The purpose of the game is to determine which player can press their button first, lighting up their respective LED while locking the system from any further inputs. The system works by continuously monitoring the state of each button. When the game begins, both LEDs are off, waiting for input. Once one of the players presses their button, the corresponding LED lights up, signaling that the player has won. The game then locks, preventing the other player from pressing their button to avoid any conflicts. The reset button restores the system to its original state, turning off the LEDs and re-enabling both buttons for the next round of the game. This project emphasizes several important concepts in embedded systems, such as real-time input handling, efficient use of microcontroller pins, and the importance of resetting a system to ensure it's ready for subsequent operations. It demonstrates how simple components like buttons and LEDs can be used to create interactive systems that respond to user input in real time. Through this project, I've gained valuable hands-on experience with microcontroller programming, pin configuration, and understanding how to build basic logic for input-output handling. This type of project can be scaled further into more complex systems with more inputs or additional game logic, but it serves as a solid foundation for interactive embedded applications. To create a two-player button game using an Arduino, you'll need several components: an Arduino board, like an Arduino Uno, 3 momentary push buttons for player 1, player 2, and a reset function, 2 LEDs to represent each player, resistors, 10 kW for the buttons and 220 wires for the LEDs, jumper wires, and a breadboard. Start by wiring the components on the breadboard. Connect one pin of each push button to the ground, G&D on the Arduino, and the other pin to separate digital pins, player 1's button to pin 2, player 2's button to pin 3, and the reset button to pin 4, with a 10-core pull-down resistor between each button's signal pin and ground to prevent floating input. For the LEDs, connect the anode of player 1's LED to pin 8, and player 2's LED to pin 9, while the cathode of each LED connects to ground through a 220-ohm resistor. Ensure all grounds are correctly connected and double-check each button and LED's connection to the respective Arduino pins. Next, write the code in the Arduino IDE. Start by defining the digital pins for each button and LED, and use pin mode in the setups function to specify the button pins as inputs and the LED pins as outputs. In the setup, turn off both LEDs by writing low to their respective pins. In the loop function, constantly monitor the state of each button using digital read. When one button is pressed, returns high, light up the corresponding LED by setting its digital pin to high while locking the game to prevent further inputs. Implement a reset function by checking the state of the reset button in each loop cycle. When pressed, it should turn off both LEDs and reset the game state. To avoid both LEDs lighting up simultaneously, create a variable called GameActive to track if a button has already been pressed. In testing, by pressing either player 1's or player 2's button, the corresponding LED should light up, and no other input should be recognized until the reset button is pressed. Pressing reset should turn off both LEDs, allowing the game to be ready for another round. This mini project effectively demonstrates the creation of a simple interactive game using buttons and LEDs, showcasing key concepts such as real-time input processing, state control using flags, and the efficient use of digital input and output in embedded systems.